Hi everyone. I thought I would just share this little informal video of me using Gearify for a particular application. Um, it occurred to me I've made a bunch of videos showing the individual features on a step-by-step basis, but I haven't made really a video of the kind of start to finish process. This is going to be totally informal. I'm not going to edit this down to be super concise. Um, but hopefully it'll give you a picture of kind of the full process and how it fits together and how I wanted it to work. And as I was working on this particular problem, it just occurred to me that this was a really great example, a really great story of how the software is used. And I thought I would basically replicate the same process while recording so that you all could appreciate. Some of you already have the software, some of you will be getting it soon. So I thought this might be a bit eye-opening and help understand how things fit together. So the goal is, I demoed this in one of my earlier videos. This is a Ellipse gear assembly that's very, very fun to play with. And a lot of people had a very positive reaction to this particular design. And my one friend in particular wants me to make him one. And but he wanted it to be a bit smaller. Now this is about 6. So the axles are very offset, as you can probably tell from the motion. Maybe you can see there kind of where the axles are. Yeah, it's hard to do this on a video. There and there. It's 6 inches. This is a lot harder to do than it looks. 6 inches axle to axle. And he said that he would like it more if it were a bit smaller, so it could just kind of this is kind of big, kind of bulky. I mean, it's still fun to play with, but it is kind of large, cumbersome. So making it half the size was his request. So half the size. So we're going from a 6-inch axle to axle distance to a 3-inch axle to axle distance. That's the specification 1. But the other specification is that I'm going to be cutting this, or my father's going to be cutting this with his CNC machine, and about the smallest end mill he can use to mill this is a 3/32 inch diameter end mill, which is about roughly 0.1 inches in diameter, which is a 0.05 inch minimum interior radius. So those are the two constraints: 3-inch axle to axle distance and a interior radius on the design that's no smaller than 0.05. So let's see if we can actually make that with Gearify and how much of a challenge it is. Okay, so this is, as an input gear, an ellipse where the center of rotation is at one of the focal points. I do want it to be left to right symmetric, but it's only one rotational copy, so I use a radial symmetry of 1 with bilateral symmetry. And click Begin Design. I'm going to use a formula for this. I happen to know that, now I could do this via point and click and whatever potentially, but to get a really nice ellipse, I'm going to use a mathematical formula. This will actually give me a really nice ellipse centered at the focal point. It's only giving me 1/2 because I used the bilateral symmetry, so the other half is just going to mirror the first half. I say trace. Great. And I've already got a nice elliptical input gear design with the center of rotation at the focal point on the right. Proceed to next. All right, I just want one mating pitch curve, also with just a 1-lobe symmetry. So that's also super easy. Proceed to next. Okay, So now here's an important bit. So first thing I'm going to do is I'm going to say Gearify, just using all the default dimensions, and that already looks pretty good. But one thing I'm going to want to control for is I want to figure out, first of all, I want the gear to be the appropriate size, and I want to also make sure that the interior radius does not fall below that 0.05 radius dimension, so that you can mill it with the minimum end mill size that I have available. So I need to set the scale of this thing effectively before I can actually read or understand or make sense of any of the dimensions. So I click Set Scale, and I'm going to use the default, which is the Ref1 to Ref2 distance. So basically that's going to be the axle to axle distance, and I want that desired dimension to be 3 inches in my case. Now, dimensions in Gearify are always unitless, so I'm just going to make it 3. And then I click Scale to Dimension. Okay. So there are different numbers of teeth I could use. The other gear assembly used 32 teeth total. But notice now that I've actually set the scale, I can actually read this min radius dimension, and it's actually correct at this point since the scale has been set. Now that's too small. So basically, if I make it the same number of teeth as the last design with the axle to axle distance of 3 inches, it's falling well below my 0.05 minimum for the interior radius, because you wouldn't be able to get an end mill into these interior corners. It would just cut away too much. It would not accurately capture the design. So what I want to do is I want to increase the number of teeth so that each gap is larger. And I think actually 20, which was the default, may be a good value to shoot for. And it appears that it's correct, that 0.053, so we're above that 0.05 margin. So already it looks like we're in pretty good shape. So let's proceed, just sticking with all these defaults. Let's proceed with the default parameters, and I'll try the trimming step because we gotta get rid of these interior intersections now. So I'll leave it at the fast setting because that's really good for prototyping and also for demonstration purposes. Probably would use standard if I was actually gonna, produce this exact design. Now that looks pretty good, but there's a small problem. Notice how the tips on the pointy ends were seriously clipped off, like massively clipped off, and the flatter end teeth not so much clipped. These are kind of more pointed, and these are kind of much more blunted, and I don't like that. First of all, I don't like it aesthetically, but also operationally I don't like it, because if you watch those, so I have the show context here, these green dots. If you watch that right about this point here, you can see that here we are, right there. You see that brief moment, and I think it'll happen again at this point. Slow it down a little bit. You see when that point of contact drops off there. Now I have just one point of contact between the two gears, which is not good. I want at least 2 so that it's pinched and that it doesn't slip out. So not spectacular. And I believe that a reason that this was so aggressively sheared is because there wasn't enough room in these interior fillet curves to allow for that tooth tip to breathe effectively. There's enough room for it to pass through, so these tips got clipped. I can even say reset. I can say begin trim, and you can see how it's really getting clipped in these interior regions. So what would be nice is I'm going to go back here. It would be nice if I can apply a little bit more room, a little bit more depth in these interior fillets. So how can we do that? Well, first what I can do is that there is a parameter for that. If I select my gear and I go to the fillet proportion, now by default it's 0.5. I won't go into exactly what that means at the moment, but effectively if I increase that proportion, I'll get a larger depth in these interior fillets. They'll cut deeper effectively. So I'm going to use an interior proportion of 0.65 instead of the original 0.5. Say set global, and then click Gearify again. And notice how those depths now increased after I changed the dimension and Gearified. Now I have a deeper cut there. And that's all well and good, but honestly, I really only need the deeper cut on this side. The cuts got a lot deeper on this end as well, and I don't hugely love the aesthetic. I'm fine with how it looks over here, but over here, this is superfluous because I already had plenty of clearance. So how do I handle that? So what I'm going to do is I'm going to add a control point here. I'm going to add a variation to it. Instead of being uniform, I'm going to control that fillet proportion. So over here, it's 0.65. Here it's 0.65, but I just added another control point, and I'm going to reduce that control point down to 0.5. So now if you look at that sample value along the curve, that fillet proportion varies from 0.65 on the ends to 0.5 here. And I'm going to do the same thing with the other gear. I'm going to add right in the middle there, just add a control point. I'm going to reduce its value to 0.5. So then we've got that nice smooth variation. Okay, so if I did this right, when I click Gearify, you should see, if you watch like right around here, you should see that jump in and be a little less shallow after the calculation. Perfect. Okay, yeah, it worked exactly as intended. All right, cool. So I've made these interior fillets deeper, so hopefully I get less shearing of these tooth tips at the pointy ends. So now that we're good on that, I'm going to say begin trim. And it does look a lot better. See, we're now actually, with the trimming, we have a lot less blunting of the tooth peaks. So much better, at least aesthetically. But let's examine it now and see, actually, are we still getting enough contact between these tooth tips? And I'm going to just kind of roll this forward, and it looks like there might be trouble. I'm not sure if this is going to pass the test. See, we've lost it. So now we only have one point of contact now right here. And even though that was significantly better, we have a lot less truncated tooth peaks. We're still missing some contact in that region back here. You can see when it drops off again. Yep. Yeah, it's just not quite enough. All right, so now what do we do? Okay, we've improved the aesthetic and we've definitely made a little bit more clearance, but we're still not quite getting as much contact as we would want. So let's tweak the parameters again. You see when I go back, the trimming is removed, but that's okay. We can redo it in a minute. What usually helps a lot when you have not enough contact in very tight, very high curvature areas is to increase the pressure angle. So I'm going to select my gear, go to the pressure angle. By default, it's 20 degrees. I'm going to uniformly set it to 25 degrees total. And then I'm going to recalculate the gear. Okay, so that looks pretty nice. It's just a slight increase in the pressure angle. The tooth forms are a little bit wider. So I'm going to proceed to next and say begin trim, and look at this. And this is actually fantastic because with this adjustment, the amount of tooth that was trimmed is actually zero. This already has perfect clearance, even though the trimming, is a perfectly valid thing to do. Turns out nothing actually needed to be trimmed. Everything was just in great shape with the existing parameters. And then let's check out this, kind of back it up a little bit. Let's check out these points of contact here. And look, we actually have, like, first of all, we start here. We have a decent amount of contact. We have 3 points of contact here. And then roll it forward. We have 2 right now, but still holding steady at 2. And we see that third point of contact jumps in before this point of contact exits, which is perfect. That's exactly what we want. So we're not losing that grip on the tooth flanks, so nothing is going to slip out. And great, yeah, it looks really good. And on the flatter regions, you actually see there's a lot more. Let me slow it down so it doesn't jump. The flatter regions, you see you have plenty of contact. Sometimes you have 3, even 4 points of contact in some moments. So that all looks really good. But what I had done before was after that, I said, cool, that looks great. And I proceeded to the DXF exporting, and I was looking over my design, and I realized that I missed something because, again, I want those interior curves to have no less than a 0.05 radius 0.05 radius interior curvature. But I realized that after I changed the pressure angle, I forgot to check my minimum fillet radius, and it's fallen below that 0.05 radius, which is in my specification. So these dimensions are too small. It's already too small of an interior radius to cut. Can I fix that? Well, there's a way to handle that too. So one of the parameters that I can use is go to min-valley proportion. Now this proportion actually controls how wide that gap is, and I can increase the proportion from 0.5 and make it a little bit bigger, and that gap will actually widen. And that probably, because notice how on this side the radius seems to be pretty big because it's covering that distance between the flanks, but it seems like here is more where the trouble is. But this is a minimum, so if I increase the minimum a little bit, these should be affected, but these shouldn't be impacted so much, assuming I choose the right value. So I'm just going to nudge this up to 0.55, say set global, and I want you to watch this interior fillet here after I click Gearify. And cool, now those widen just a tiny bit, and now you can see that min visible fillet radius or fillet radius is now just above the specification, which is fantastic. So let's try rolling it again. And as I expected, it's still totally fine. I mean, all we did was increase the clearance a little bit, but it's still good to do this step just to double check. Okay, so first thing I'm going to do here is I'm going to include my pitch curves. I'm actually going to use an axle diameter of 1/8 inch, so 0.125. So I've got those axle diameters there. And yeah, this is looking pretty good. So let me just kind of get it into a position that where I want the export to be. Let's stop it right about there. That looks good. And I'll say export. Gear Ellipse demo. Save. All right, and we've generated the design according to spec. Okay, so here's the completed design. You can see that all the dimensions are according to spec. I added these annotations, and I also drew a little 3-point contact circle at the smallest interior curve here and measured its diameter, and you can see that it's exactly within the minimum requirement, so that we can mill it out with the 3/32 inch end mill. So yeah, looks like everything came out great. And here's a nice clean drawing of the finished design with no pesky annotations in the way. So yeah, I hope that this gave you an idea of the power of Gearify 2.0 and how quickly you can design and prototype and check out the issues and make adjustments to the parameters and make something that is the size and spec that you want. So cool. Hope you enjoyed. Thanks for watching.